Hello everyone. Today in this vlog I'm going to show you how to provide a replicated storage for your Kubernetes cluster using the OpenEBS technology. As you probably know already, in the world of the containers everything is dynamic. So our pods are created, destroyed, replaced, upgraded, basically or even moved between the nodes in any time. But applications that are running on our Kubernetes need to be reliable and connected to the persistent storage. So basically, that's where the OpenEBS comes in. It's a cloud-native storage solution that runs directly inside your Kubernetes cluster and allows you to build flexible, scalable, and most importantly, replicated volumes for your workloads. This is what we actually required. In this vlog, I will cover a few things. The first one is we'll take a quick look at what OpenEBS is, how it fits into our Kubernetes ecosystem. Then we will go directly to the concept of the replicated volumes because actually that is the most important concept, and we'll talk about why they matters for the stateful applications. Then we'll go to the step-by-step installation guide for the OpenEBS on the Kubernetes cluster, and I will demonstrate how to create a dedicated replicated storage pool and create respective storage class to use and to use for our stateful application workloads. And finally, I will run a demo application that will use that storage that we created previously. So we will present the full chain, the full process of provisioning. Before we dive in, I will also want to quickly introduce myself. My name is Marcin Kujawski. I'm principal software engineer at Software Mind Company. You can reach me directly via email, or if you want, also LinkedIn profile here. I have quite wide experience regarding the Kubernetes technologies. I've been deeply involved in Kubernetes for quite some time, especially for topics related with storage and infrastructure. Over the years, I have helped customers designing and running multiple Kubernetes clusters in multiple environments, production environments, I'm really enjoying that I can share this knowledge to you guys, so also others can get hands-on and confident with those technologies as well as I am already doing. So I am working with in a Software Mind. Software Mind is a high-tech company that builds custom software solutions. They provide the full development teams that can handle everything from the start to the finish, with very high expertise in, of course, cloud, AI, and data science, of course, and multiple fields. We are just helping customers and businesses transform digitally from one way to another to improve the services, and the atmosphere in the company is really nice. So really enjoying that time. Of course, also if you wanted to join, feel free. Regarding the OpenEBS, what it is and how it's let's say suited to our Kubernetes. The OpenEBS turns any storage, any local connected storage that is presented on the nodes into the local or replicated Kubernetes persistent volumes. What it means? It means basically that if you have some local disks or even NFS connected to the local nodes, local Kubernetes worker nodes, you can transform them into the distributed storage basically. So you can combine multiple local storage devices into one logical distributed storage pool, I would say. Yeah, so this is really awesome and really good technology to follow. The OpenEBS helps application and platform easily deploy the Kubernetes stateful applications, and it is actually aiming the container native storage solution, so CNS in short. So container native storage means that you can run it on any kind Kubernetes aware environment, and it would be basically implemented in the same way. The OpenEBS itself is also a leading choice currently for the NVMe based storage deployments, which means that many companies are actually using it right now, and it's really yeah, good thing. Yeah. The main concept for the OpenEBS are the local volumes and replicated volumes. In terms of the local volumes, this is also something that we actually want to get rid of our Kubernetes cluster, because it sticks only to the single nodes in the cluster. So this is something that we don't want to use basically, because the persistent volumes are just subdirectories on the nodes that application is running on. So basically nothing special and nothing, let's say, high available, I would say. Yeah, so don't want to use it. But the second approach with replicated volumes is really something that is, reliable and something fancy. So what OpenEBS is doing while implementing the replicated volumes is that it creates the NVMe targets accessible via the TCP network. And for each target, it's creating the persistent volume. So basically something that is, of course, available for all nodes in a cluster. So replicated volumes have data synchronously replicated to multiple nodes in a cluster. So volumes can sustain node failures. We are eliminating the single point of failure, and basically we are meeting all requirements for our stateful applications. And here we have the architecture slide where I present the demo scenario more or less. So I have the Kubernetes cluster running on the hypervisor, which we created. We have 6 VMs, 3 for the control plane, 3 for data plane. And on the right hand side, you see that this is also a true NAS server, which is indicating the iSCSI array and simulating iSCSI array. So basically we have freelance created that they will be that they will be exposed to our worker nodes on the network, and the worker nodes can mount it as a local drive. So basically I can mount over iSCSI protocol in each worker node, separate or standalone LAN from my iSCSI target. And once I will do it, then later on I will combine them together and create one single disk pool on my Kubernetes server, Kubernetes cluster. I will create disk pool resource definition. It's a custom resource definition of Kubernetes that OpenEBS is creating, and it's actually using all those 3 devices, all those 3 local devices in terms of worker node perspective, and transfer those 3 worker nodes local devices into one single disk pool that is actually available widely on a cluster for our workload applications, for our stateful applications. So basically we can use that storage pool widely on a cluster for any kind of application we want. Yeah. For a demo purpose, I simulated this block storage with a true NAS server, which is actually exposing me freelance via the iSCSI protocol to my worker nodes. On a Kubernetes part, I have this deployed the Linux 64-bit architecture operating system. I think it's a Rocky Linux, with a distribution RKI2 Kubernetes cluster with 6 nodes, 3 worker nodes, and 3 control plane nodes. And that's it in terms of the presentation. Of course, if you are interested more about the Software Mind company, which is really awesome, please stay in touch either by the newsletter, or if you want to learn more about what we do and what we are involved in, you can also contact us directly via the LinkedIn or Facebook or even Instagram. All right, thanks for this part. Let's kick it off and let's start doing it. So if you can see, I have a cluster which is containing 3 control plane nodes and 3 worker nodes, and now I will try to install the OpenEBS solution on top of it. So first of all, we need to go to the official documentation, which is the openebs.io. And if you go to the get started, and then later on to the quick start guide, we have the prerequisites. and I will talk about it in a minute, because it actually contains few remarks that are quite important in terms of preparing the worker node. So we need to enable some modules. Also, you need to have the huge pages support enabled. So we have a little bit configuration steps here. All steps are listed here, so it's not rocket science to do so, but I will dig into it in 5 minutes. But the installation itself is just actually presenting the whole, let's say, setup of the EBS, and it's actually straightforward because it contains of first of all adding the Helm repository, and then proceeding with the Helm install, and then actually you have it. So it's quite straightforward. Let's Control C that and Control V here. So let's add this repo and repo update. Yeah, so we already have it. The next thing, of course, is to install the OpenEBS. I will use the same command as here. It's a default one. We don't want to override any values. It's okay to just copy it and paste it. Okay, let me export the kubeconfig. And let me do the same again. And it will take a little bit, so let me open the duplicate console here. So if I go to kubectl, maybe let's connect it to my cluster first. And let's connect and check what is going on. So watch -n1, kubectl get poll -n OpenEBS. So this would tell me, what is going on the cluster. So as you can see, the pods are creating in a container creating state. It will take just a few minutes to complete it. Yeah, as you can see, there are quite few components to be installed. So OpenEBS is a quite big engine of all the applications connected to each other. But basically, it's a really good thing for a cluster if you wanted to have the replicated storage connected. So that's really awesome. So let me just wait a few minutes until it will be done. And in the meantime, let's just prepare the nodes. So as I told you already, we have the prerequisites that we need to meet in order to provide the proper worker nodes. So first of all, we need to connect the iSCSI targets. So let me close this one, and let's connect to the worker nodes. So okay, this is the first one. And now I wanted to actually proceed with a few things. First of all is start iSCSI service. So it's iSCSID. So systemctl enable now iSCSID. Okay, let's check the status. It's active and running, so that's fine. The second thing is iSCSI IDM, which will discover my target. And my target is my TrueNAS server, which has the IP address 192.168.1.80.93, sorry. Mode discovery. Okay, so we can see that it's actually seeing all the targets that I have on my TrueNAS. So we will choose this one, this IQN, to connect the storage to the worker one. So iSCSI ADM -m node -t my IQN, and then -p my IP and -- login. Okay, so login into the IQN goes fine. So we have successfully connected IQN, and then I need to repeat that with options that will actually guarantee that the iSCSI will auto mode it after each restart of the VM. So each restart of my Worker 1, Worker 2, Worker 3, it will be automatically setting up this this storage. So op update -n node.startup, and we provided -v automatic. Okay, I think looks good. So let's check it if we can see our iSCSI in lsbl key command. So as you can see, we have SDB, and this is the disk that was connected directly from the TrueNAS server. So we have iSCSI resource on the node, and I would also get the ID of that by ls my dev disks by UID, and yeah, actually SDB device is actually this one. So to be honest, I can use one of those, either this one or this one or this one or this one. It doesn't make sense actually to use all of them. I just pick this one, maybe the first one that is connected and linking to the proper SDB device that is connected through the iSCSI. So I will gather this one, I will copy it, and I will save it for the further configuration. We will require that to create this disk pool once OpenEBS is installed. So that will be provided later on. And I think for the Worker 1, that's it. So let's proceed with the same on the Worker 2 and Worker 3. So let's log into the Worker 2. And actually I will do the same commands. systemctl enable now iSCSI D. Okay, and then I will use the command to discovery. Yeah, that's the same. Okay, I see also that it's seeing the same thing, so yeah, that's good. Then let's do the login thing with the Worker 2 IQN. Okay, Worker 2 is fine, and then let's do the same thing with the update to auto start the resource once the server is restarted. All right, have it, and yeah, lsbl key as same. Okay, we see also the disk 100 gigs and ls-la dev disks by ID, and we have also the Worker 2, which is also something I wanted to get and notice. All right, the next one is the last one. So Worker 3, and actually the same set of commands. Yeah, so first of all, enabling and starting the iSCSI daemon. Yep, then discovering the targets. Yeah, and the same thing with the login and reconfigure for the auto start. Okay. All right, lsbl key again, lsbl key. Yeah, we see the disk SDB and ls-la our dev disks by ID, enter, and also we see that SCSI Worker 3 resource is available. Okay, copy it. Then if we go to the master node again, so let me close this one. You see that this Helm chart was successfully installed. So we installed OpenEBS Helm chart. We can of course do this command to double check and validate if we have it already running. What is missing is the OpenEBS IO engine missing, but the IO engine actually need to be installed on the nodes that have proper label assigned. So what we need to do is prior to the storage configuration, we need to label the node. So I will label the Worker nodes like Worker 1 with a label that is also mentioned on the official documentation, and you can see it here. So preparing the nodes, and you see that kubectl label node with the specific label need to be configured. So I copied the link, copied in the label, set it here, and I need to repeat it for the worker 2 and worker 3 as well. All right, looks like we have it. And now I go to the kubectl get pods. You will see that 3 IO engines are being initialized. Each one is actually installed on the each worker node based on that label that we already set. So basically that is something that is directly responsible for creating the device that would be part of the disk pool later on. Okay, but three are running, and of course this is a daemon set, so it's one per node. Yeah, so now I think we can start with the disk pool creation. So let's create the simple YAML file. I will maybe call it pool worker1.yaml. Okay, and I will copy here the template that I already have prepared up front, which is the pool worker1 disk pool for the namespace OpenEBS for the node worker1, and this is actually the SCSI ID that we copied previously. So this is important because you need to set it properly here. Of course, you can just specify the disk name like dev SDB, but the ID is more safe, and it guarantees the unique string that cannot be simply duplicated. So that is for worker 1, and actually I wanted to have the worker 1, worker 2, and worker 3 that would actually use this the same SDB device that is connected through iSCSI. So I will quit it, and I will copy that file into the worker 2 and worker 3 as well, because we need to have each per node. So let's go to the pool worker 2 and let's change it. So for worker 2 it would be pool worker 2 name, and node is worker 02, and this SCSI ID is of course different. So let's use the valid for worker 2, which is actually the value we gathered previously. All right, and the worker 3 as well. All right, so change the name, change the node, and change the SCSI identifier. All right, we have it. So we have created 3 pools containing each containing 1 disk, and let's apply it right now. So kubectl, I will just get dsp -a, so you will see that there is no resources found. Actually, this is namespace OpenEBS to be precise. Yeah, so no resources found in OpenEBS namespace. If we use the kubectl apply button -f pool worker 1 -f pool worker 2 -f pool worker 3, I will create yeah, .yaml maybe would be better. Yeah, let me correct it. All right, so we have 3 disk pool objects created. So now if I go with the get dsp -n OpenEBS, you will see that they are creating state. Yeah, so let's watch -n kubectl get dsp. It's a short for a disk pool OpenEBS. Yeah, you will see that it will be created in a minute. Yeah, it's online already. So it's, you see that it took, I know, maybe 15 seconds, maybe half a minute, but we have quite fast pool created. We have capacity 100 gigs, so this is exactly the size I presented by node. So all is good. Pool worker 1 on worker 1, pool worker 2 on worker 2, and pool worker 3 on worker 3. So that's brilliant. And now the last thing we need to create is storage class. So to To be honest, if I get my storage class that I have currently, you will see that I have some created already by Mayastor and OpenEBS plus the local path from Rancher. But basically, we need to create a storage class that will be, as a reference, they will use the provisioner for my IO OpenEBS CSI Mayastor and will be based on my pool that I specified. So let's create maybe iSCSI OpenEBS replicated. Let's name it like that. And let's create it. So what is inside here? We see that, of course, this is APF version for the storage class, kind of storage class. The name that I have the same as my file. Provisioner, this is important thing. So we have this IO OpenEBS CSI Mayastor. It's the same as we see on the previous one. Of course, we can check the storage classes and you will have the same. Parameters, two things. Replicas number is a 3 because we have 3 nodes and 3 storage devices, and protocol NVMe. This is like a hard-coded value here, so just leave it as it is. Reclaim policy, by default I set it to delete to have the dynamic provisioning, and the volume binding, wait for the pod, so wait for the first consumer. Let's close it, let's create it, and yeah, let's see what's going on. Okay, kubectl get storage class. Okay, the replicated storage class is here. So actually we are ready to deploy the test application. So now I wanna use maybe WordPress application through the Helm chart also to deploy it and to see if my PVC would be bounded with the dynamically created PV from my storage class iSCSI OpenEBS replicated. So what I wanted to see right now is my PV and PVC. So in my default namespace, I have no PVCs, but PV on the cluster, you see it's only 2 gig, and this is more or less for OpenEBS itself. So for OpenEBS data, for OpenEBS controller. So what I wanted right now to do is I would add the new Helm chart, Helm repo, which is Bitnami. And from Bitnami, we will install the example demo application that would be WordPress. Okay, Helm repo update. Yeah, it's done. And let's deploy the application. In my case, it would be Helm install, of course, or maybe upgrade with install flag, and use my WordPress as a name from Bitnami and WordPress chart. Then use the namespace dedicated for it, so maybe WordPress, and create namespace if not existing. And now I need to specify a few things. So first of all, I need to override the parameters that are related with my storage class, and I also wanted to have the service of my WordPress to be available as a node port. So I would press few parameters here. Now I would type few parameters here. So let me copy it and paste it. So as you see, I'm using the service type as a node port, service node ports as HTTP 30080 and for HTTPS 30443. I will use the global storage class as iSCSI OpenEBS replicated, so that is my class I already created. The persistent storage for the MariaDB and the WordPress the same, and volume permissions enabled equal true, so it will persist my storage on my storage class. So let's install it. The release is already installing. Yeah, we have it. So let's also watch it. Watch -n1 kubectl get pods -n WordPress. Okay, you see that we have MariaDB and WordPress. MariaDB is still in a init container phase. Yeah. Okay. We have pattern slicing and DB is already running. It's not yet ready, but it's running. So yeah, good sign. Yeah. Also the WordPress is starting. Let's double check our storage because this is the most important thing. Get PV and PVC from namespace WordPress. So as you see, we have the storage class. We have two actually claims, one for the WordPress frontend, one for the backend MariaDB database. One is 8 gig, one is 10 gig. So if you see the storage class is proper, the bound is correct, and I see also those two PV created here. So this is the one, and this is the second one. Yeah, looks good. Our storage class is working. Dynamic provisioning is fine. So let's kubectl get dsp-a, and you see that we have already used 18 gigabytes of the resource. So we have available not 99 but 81.9. Yeah, so those actually numbers are calculated in that storage already used. So yeah, that is properly functioning. Let's get the pods. Yeah, now they are running. Let's try to log into our application and see if this is working. Yeah, so I think it would be good to just start it. So it was not port. So let me open the HTTP or HTTPS even 192.168.181. This is my master node on port 443. Yeah, I wanted to visit it, and yeah, that is our application. So even if I now restart the pods, restart the deployments, restart it, and the application will go down and up again, the persistent storage that we use for the application will be still there, the data will be there. So yeah, that is everything actually that I wanted to show you. So yeah, of course we can go with with the admin login and fully manage this application. Of course we can dig the password and log in, but this is not the aim of it. It was just to evidence that we can simply create the OpenEBS, configure the storage pool, configure the storage class, and use it to deploy our stateful set application that is using the persistent storage on the cluster. Okay? Yeah. Okay, so that's it for today's session on providing the replicated Kubernetes storage with the OpenEBS solution. We actually walk through the what OpenEBS is, a couple of slides, why we wanted to use the replicated volumes, how they are important for the stateful set applications and workloads, how to set up the OpenEBS controllers, how to basically install it, how to create a pool, how to create the volumes that are let's say part of the demo for our application. Also, you need to remember that the key takeaway actually is that the OpenEBS is the perfect solution if you don't have to rely on external storage systems. Yeah, so if you can run everything indirectly inside the Kubernetes cluster and still get the reliability of the replication across the nodes, then that is super solution. Basically, it's powerful also to keep your data safe and ensure, and to ensure that your applications keep running even if a node, for example, goes down. So if I would now shut down one of the node where the application is running, then it's all protected, it's all good. So I hope that this walkthrough helps you to get started with that, and I inspired you to try with OpenEBS in your environment. I hope you enjoy this video. Feel free to like, share, and subscribe if you want. And yeah, thanks for watching, and see you next time.